behavior. Recently, I have published a paper in which I argue that logical inferentialism should be carried out in a formula framework. And I've provided formula natural deduction calculi for classical intuitionistic propositional logic. There are, however, some problems in the paper that I have published because I considered only propositional logic, and moreover, the sequent calculi that I have proposed were unsatisfying. They were fine because they were used only as byproducts to prove things about the natural deduction calculi, but nonetheless, there were problems. First of all, I don't have cap elimination in the systems that are in the paper already published. So what we are trying to do in this work, that is still a work in progress, together with Camillo, is first of all is to extend this formula inferentialism in various ways. First of all, to go from natural deduction to sequent calculi. So we want to focus mainly on sequent calculus in this paper, not only as a byproduct of natural deduction. Then we want to go from propositional logic to first-order logic. And third, we want to add dual intuitionistic logic to the positions repertoire of logics that we discuss. And of course, we want to have cut-free calculi. Moreover, we want to avoid appealing to the empty set of premises and conclusions for reasons that I will explain later. In addition, we will argue that under certain assumptions, and we will try to be as general as possible regarding these assumptions, all our calculi satisfy reasonable principles of harmony and non-circularity. So the plan is essentially this. First of all, I will explain why I think that formula framework is the best framework for doing proof-theoretic semantics in this sense, so for investigating the meaning of the logical terms. Then I will present some standard calculi, standard in the sense that they are multiple, so multiple premises and multiple conclusions. And I will explain how they can be adapted in formula framework. Then we will evaluate these calculi. We will propose some criteria and we will evaluate the calculi using these criteria. And then I will conclude. So first of all, why formula? Now, there are various authors that have suggested that multiple conclusions might not get along with logical inferentialism. As an example, Ramfit, Tennant, and Camillo Fiore himself. The most echoed argument to this effect, and then one that we will focus on, was put forward by Dummett in The Logical Basis of Metaphysics and then developed by Sternberger. We call it the circularity objection, and it can be summed up in this way. We have 4 premises and 1 conclusion. The first premise is that a system of rules is acceptable from an inferentialist standpoint only if it provides a plausible description of what a speaker who is innocent of the meaning of the logical constants has to grasp in order to become competent in that meaning. The second premise is unilateralism, that is the standard reading of the sequent. That is, the sequent is interpreted as saying that whenever it is admissible to conjunctively assert the antecedent, it is admissible to disjunctively assert the succedent. Third premise, to conjunctively assert A, B, so the antecedent, is tantamount to assert A and to assert B. Hence, a speaker can master the conjunctive assertion of A and B without knowing how to use the particle and. The fourth premise is that to disjunctively assert CD, that is, the succeedent, is not tantamount to assert A or assert B, but it is tantamount to assert A or B. Hence, a speaker cannot master the disjunctive assertion of C and D without knowing how to use the particle or. Now, interestingly enough, Dummett and Sternberger have different arguments for this fourth premise, but nonetheless, both of them agree that this is a valid premise. And the conclusion that they propose is that a system of rules with multiple premises is acceptable from an inferentialist standpoint, while a system with multiple conclusions is not. Now, a standard reply is essentially to drop the second premise, so the unilateral reading of sequence, and propose in place the bilateral reading. According to this reading, a sequent says that it is never admissible to conjunctively assert A and B and conjunctively deny C and D. This position avoids the circularity objection because it does not assume prior knowledge of the disjunction, but it assumes a competence in rejecting statements. We will not go in this direction. We do not forfeit the second premise, but we reject the third one. Okay, so we argue against the multiple premises. Now, for the sake of the argument, we concede that asserting A and B is for pragmatic purposes tantamount to asserting A and asserting B. However, what we do not accept is that our capacity to assert A and assert B is either conceptual or empirically prior to our capacity to use AND. Such a conceptual or empirical priority should be justified on a rigorous philosophical or empirical basis, and we claim that there is no such justification. Indeed, there is even some kind of philosophical work that seems to suggest the opposite thesis. Indeed, Susansky suggests that an agent who does not yet handle conjunction could not possibly master multiple assertions, and so could not learn conjunction by its introduction rules. What Susansky proposes is essentially some form of the adoption problem, the famous adoption problem for modus ponens and universal generalizations, but for the introduction rule for conjunction. Thus, for all we know, the meaning of conjunction and of multiple premises can be and probably are interdependent. But then, considering the remaining premises of the circularity objection, systems with multiple premises are not acceptable from an inferentialist standpoint. To be clear, what we want to say is not that the problem is that multiple premises are not appropriately related to our inferential practice. Of course they are. We always use multiple premises. The problem is different. The point is that systems with multiple premises are suboptimal for the kind of search that an inferentialist project undertakes. For these purposes, we argue a formula-formula system is more appropriate. Now let's see the standard calculi that we start with and that we use to construct the single calculi. Now the language is the standard one. Okay, the only strange thing, if you want, is the use of subtraction. And I will explain it, of course. We use, of course, the standard notation for formulas and the sequences of formulas. This connective is called subtraction. It is the standard connective in a dual intuitionistic logic. For reasons of symmetry, we deal with subtraction in all the calculi: intuitionistic, dual intuitionistic, and classical. Now, for classical logic, we stay with Gensen's original LK system, essentially. So we use lists of formulas instead of sets or multisets. While for intuitionistic and dual intuitionistic logic, we propose calculi in the style of Mehara. That means essentially that we will restrict the number of sentences on the left and on the right of the arrow only when it is needed. So we will have multiple systems both for intuitionistic and dual intuitionistic logic with some restrictions on some rules. We start with the basic calculus that can be extended for classical intuitionistic and dual intuitionistic logic. We have, of course, the rule for identity, the structural rules. Consider that we have also the rule of exchange because we work with LK. We have the rules for conjunction and disjunction, and the basic calculus have the rule of introduction of the universal quantifier on the left and of the existential quantifier on the right. Now, starting with this calculus, we can obtain classical logic just by adding these rules. Okay, so the standard rules for negation, implication, subtraction, and existential on the left and universal on the right. Starting with the same basic calculus, we can obtain an intuitionistic system by adding the classical rules for the introduction of negation, implication, subtraction, and existential on the left, and the restricted version of the rules on the right. In this case, we have a restriction on the number of formulas on the right, and we have a strange formulation of the rule of negation and especially of subtraction. The dual, of course, is done for dual intuitionistic logic. So we have, of course, the same basic calculus. This is extended with the classical rules for negation, implication, subtraction, and universal quantifier on the right, and a restricted version of these rules on the left. Now, these systems have an interesting property. First of all, we say that the sequent is gamma delta is empty free, just in case neither gamma nor delta is the empty set of formulas. So essentially, if neither the antecedent nor the succedent is empty. And this calculi in general have this interesting property. If a sequent A arrow B has a derivation, then it has a derivation where every sequent is empty free. So we never need to rely on the empty set of formulas, neither on the left nor on the right. Of course, also these systems are adequate for respectively classical intuitionistic and dual intuitionistic logic. So we can use this calculi to build our formula calculi. We need some definitions first. In the following calculi, we use the small Greek letters for formulas that are part of the context and the Latin ones for formulas that are active. Moreover, we use this kind of expression to denote when a formula has a subformula token. So in this case, gamma has a subformula token A. There is no difference between having the square bracket on the left or on the right. It's just for a matter of symmetry, for purely aesthetical reasons that we use both of them. Moreover, if in a rule we have more expressions of this kind, so gamma A1, gamma A2, etc., then this denotes the formulas that result from gamma by replacing a fixed subformula token C with A1, A2, AN respectively. So this means essentially that A1, A2, etc. all occur in the same position inside the formula gamma. So the basic calculus is this. So we work more or less as with the multiple calculi. We start with the basic calculus and then we extend it to classical intuitionistic and dual intuitionistic. The axiom, that is the rule of identity, is more or less the same. We have a rule of introduction of conjunction on the left and disjunction on the right in place of the rules of weakening. In place of the rule of contraction, we have a rule of idempotence of conjunction and of disjunction, conjunction on the left and disjunction on the right. And notice that this rule can be applied to any superformula of gamma of this form. Instead of exchange, we have a rule of commutativity, and we also have to adopt a rule for associativity of conjunction and disjunction, since this is not obvious as opposed to what happens with the punctation mark. Moreover, we have these rules for the introduction of the universal on the left and of the existential on the right. In this case, we have to use these curly brackets. Now, this notation is taken from an old paper by Peter Milne, that is, of course, in the references at the end. The expression in the curly brackets just means that the formula are optional. So you can have and gamma, or you can not have and gamma. You can have just, you can have just AXT. And you can still apply the rule. Of course, if you have and gamma in the premise, you must have it also in the conclusion. And the same for the rule of introduction of the existential on the right. So as you can notice, unlike the multiple version of the basic calculus, the single version of the same calculus lacks rules for introduction of disjunction on the left and of conjunction on the right. The most obvious candidates are these, but these are not enough. They fall short of completeness as they don't prove distributivity. So we have to consider alternatives. Indeed, to prove distributivity, we need rules that allow us to introduce conjunction and disjunction in subordinate position with respect to each other. And we will evaluate two pairs of rules for disjunction on the left and conjunction on the right. Now, the first alternative, we call them liberal because the rule for conjunction mentions disjunction and vice versa. So these are formulated using the curly brackets that we have already defined. So we can introduce a disjunction in the context of a conjunction, or a conjunction in the context of a disjunction. The second alternative are Puritan rules. In this case, we call Puritan because there is no meaning contamination between conjunction and disjunction, in the sense that we do not need to explicitly refer to conjunction in the rule for disjunction and vice versa. But the rules are in some way more powerful because we can introduce disjunction and conjunction in every subformula of gamma or of delta. These rules are sound only if there is this restriction, that is, the string in the square brackets are not in the scope of quantifiers. If we do not have these restrictions, we have obvious counterexamples. Okay, so this one for the introduction of disjunction on the left, and this other for the introduction of conjunction on the right. Okay, so we need to impose this restriction. These rules are not applicable in the scope of quantifiers. Moreover, another observation is that this Puritan rule of introduction of disjunction on the left is unsound in intuitionistic logic, and of course the dual one of introduction of conjunction on the right is unsound in dual intuitionistic logic. Let's see some counterexamples. Now, this is clearly should be underivable in intuitionistic logic, and this should be underivable in dual intuitionistic logic. Indeed, we know that the double negation of tertium non datur is a theorem in intuitionistic logic, while this is not, as an example. Okay, of course, as for classical logic, these are sound. Okay, so we have that in classical logic, both of them are sound. In intuitionistic logic, only the introduction of disjunction on the left, the Puritan version, is sound. And in intuitionistic logic, it is sound the introduction of conjunction on the right. Now, for reasons that will become obvious at the end, we will focus mainly on systems that do not mix liberal and Puritan rules. So we will use Puritan rules for classical logic and liberal rules for intuitionistic logic and dual intuitionistic logic. Well, okay, so classical logic is obtained from the basic system by adding the Puritan rules, okay, as we have said, for introducing disjunction on the left and conjunction on the right, and this formulation of rules for implication, negation, subtraction, and existential on the left and universal on the right. Now, it is interesting the fact that some rules can be formulated using the curly brackets of Peter Milne, some of them cannot. As an example, the introduction of implication on the right can be formulated using this curly bracket. The introduction of negation on the right cannot. The reason is that we want to avoid empty sets of formulas in our calculus, and so we can use the curly brackets only in those rules that cannot introduce empty sets of formulas. The single formula intuitionistic calculus can be obtained by the basic calculus by adding, first of all, the liberal rules for introducing disjunction on the left and conjunction on the right, the left rules for the classical logic, as in the multiple version, and these rules for negation, implication, subtraction, and universal quantifier on the right. Dual intuitionistic logic can be obtained dually, of course, so same liberal rules for disjunction and conjunction, right rules for classical logic, and a restricted version of the rules for introducing negation, implication, subtraction, and existential on the left. So let's see some criteria and let's evaluate the system. Well, first of all, let's consider the simple properties. First of all, we have that the rule of cut is admissible. Indeed, we don't need to assume the rule of cut at all in our system. Moreover, the rule of identity, that is the axiom, is already formulated only for atomic formulas, which is good because Hacking proposes this criteria as criteria for logicality. Moreover, the calculi are all strictly formula, in that they do not appeal to empty antecedent or succedents. That is, you can never reach empty antecedent or empty succedents, which is also good because empty antecedent and or succedents are not easily accounted for in a single premise, single conclusion framework. Next, we present and justify two further meaning theoretic principles, one of non-circularity and another of harmony. And then we analyze which of our calculi satisfy which of the properties. Now, I will skip this because, of course, all of you know that that of course there is a correspondence between introduction rules in natural deduction and a rule of introduction on the right in sequent calculus, and elimination rules and introduction on the left. Okay. What is interesting is that there are three possible positions regarding the meaning of a logical constant, in this case hash. The introduction rule can be considered the meaning conferring. The elimination rules can be considered the meaning conferring, or both of them can be considered the meaning conferring. Now, we will be agnostic about which rule confer meaning. And we will try to evaluate the systems regardless of which rule confer meaning. What we want to do to propose our criterion of harmony is to study the dependencies that exist or do not between logical constants of our calculi. To that end, of course, we must say when the meaning of one constant depends on the meaning of other constants. And we have this definition, which I think is quite intuitive. We say that the meaning of hash depends on the meaning of star, just in case star occurs in non-principal position in some meaning conferring rule for hash, or there is a sequence of constants, circle 1, circle 2, circle n, such that star occurs in non-principal position in essentially star is used to define the meaning of circle 1 is used to define the meaning of circle 2, etc. up to hash. So essentially the transitive closure. For example, let's consider the classical and intuitionistic rules of introduction of negation. Introduction on the right, so introduction. If introduction rules are meaning conferring, then as for classical logic, we know that the classical negation depends both on conjunction and on disjunction. As for the intuitionistic rule, the one on the right, we have that negation depends both on conjunction and on negation itself, because negation occurs both in principal position and in non-principal position. Now, there are a number of attitudes one may take towards dependencies between constants. It is proposed atomism, that is, it is required that the meaning of logical constants are all pairwise independent. However, there are some objections. As an example, Milne pointed out that atomism has not received enough justification in the literature, and there are also some references both in the works of Dammet and in Schroeder-Eister. Moreover, we should also consider the fact that assuming the circularity objection is right, already the standard sequent calculi violate atomism in a flagrant manner. So what we want to do in our work is to part ways with atomism and entertain a weaker position, which can be viewed as a sort of non-holistic molecularism. We require essentially non-circularity, which is, by the way, a proposal that was put forward already by Dammet, although he never developed this proposal formally. Non-circularity requires that the dependence between logical constants is non-circular. That is, there are no constants star and hash, such that star depends on hash and hash depends on star. We argue that having a principle of this kind is reasonable because it guarantees that the meaning of the logical constants are ultimately well-founded. So we have this requirement of non-circularity. As for the other requirements, a widely shared assumption about logical consequence is that it is analytic. That is, whether an argument is valid depends only on its form and on the meaning of the logical constants it contains. Moreover, another common thought is that logical consequence should be innocent. That is, gaining logical knowledge can never improve our previous knowledge of atomic non-logical facts. That is, logic should be innocent. So we propose a criterion of harmony that is grounded on these assumptions, essentially. So a sequent calculus is weakly separable, just in case whenever a sequent is provable, it has a proof that only uses rules for constants occurring in the sequent, or for constants upon which the constants occurring in the sequent depend. This is essentially a generalization of the standard notion of separability that was, for example, used by Belknap to propose his criterion of logicality. Essentially, these two informal ideas justify the following notion of harmony. That is, a sequent calculus is harmonious just in case it is weakly separable. So we will stay just with this notion of harmony. Let's consider so the systems that we have, both for non-circularity and for harmony, that is, weak separability. When at least introduction rules confer meaning in the system for intuitionistic logic, there is a clear circularity, as we have seen, between negation and itself, and between subtraction and itself. In the same way, when at least elimination rules confer meaning in the system for dual intuitionistic logic, there is a circularity between negation and itself and implication and itself. Okay, so this is quite obvious. Otherwise, circularity is avoided. This is a little less obvious. And all systems are harmonious. This is not so obvious, but we have a proof of it. And a long and tedious proof. So the situation is this one. We have that for classical logic, regardless of the approach, so we can have only introduction, only elimination, or both introduction and elimination rules that are meaning conferring. The system is both harmonious, that is weakly separable, and non-circular. For intuitionistic logic, the system is harmonious regardless of the choice of the meaning conferring rules, but it is circular if at least introduction rules are meaning conferring. For dual intuitionistic logic, we have the dual situation, of course. So we have that the system is harmonious regardless of the choice of which rules are meaning conferring, but the system is circular when at least elimination rules are meaning conferring. Now, it could seem that this kind of situation is a little ad hoc. So we have 4 variations of the calculi that we use to argue that this kind of conclusion do not depend on assumptions on the systems that we have, on ad hoc assumptions. So first of all, one could feel worry about the puritan rules present in the sequent calculus for classical logic. So let's investigate what happens when we use only liberal rules. And let's call the resulting system SSCL liberal. Now, as for the standard system of classical logic, the one with Puritan rules, the system is harmonious no matter what position on rule priority is assumed, but it violates non-circularity when both introduction and elimination rules confer meaning. So we have essentially this system, this situation. Okay, so we have that harmony still holds for all the systems, regardless on the position about which rule is meaning conferring. But we have a problem of circularity for classical logic when both introduction and elimination rules are considered meaning conferring. Notice that also in this case, classical logic still behaves better than intuitionistic and dual intuitionistic logic. Second variation, one could think of adopting the Puritan rules for intuitionistic and dual intuitionistic logic, of course, when it is possible. We have seen that some Puritan rules are sound with intuitionistic and dual intuitionistic logic. So we could have semi-Puritan variants of intuitionistic and dual intuitionistic logic. We call the resulting systems in this way, so intuitionistic logic Puritan and dual intuitionistic logic Puritan or, respectively. And we can show that these are not more satisfactory because the potential circularity that we have already observed still hold. But there are even more troubles because in this case we have even problem with harmony. As an example, in order to introduce the double negation, that is, of course, a valid sequent in intuitionistic logic, we need to rely on disjunction, which is problematic when only introduction rules confer meaning. Dually, when only elimination rules confer meaning, in order to eliminate double negation, we have to rely on conjunction. And this is problematic because if only elimination rules confer meaning, then the meaning of negation does not depend on conjunction. So the situation is this. It is even worse than the previous one. We have that not only the system is still circular, but it is even non-harmonious sometimes. Let's consider a tiered variation. One could think of introducing a primitive top and a primitive bottom. That is in the end what is usually done, and this is, by the way, a standard objection that we receive, and define the negation using top and bottom, okay, in intuitionistic and dual intuitionistic logic. We can do this essentially by constructing this system. Call SSEL bottom the system that results from our formula system for intuitionistic logic by dropping the rules for negation and adding these rules. Of course, we can do the dual for dual intuitionistic logic. Okay, now let's see what happens. Well, first of all, the intuitionistic logic with bottom and dual intuitionistic logic with top satisfy non-circularity when only introduction or only elimination rules confer meaning, but they still violate circularity, non-circularity when both introduction and elimination rules confer meaning due to the liberal rules for conjunction and disjunction. Moreover, we have even more problems with harmony, because even to prove a simple sequence like A minus B, from A minus B you have A minus B, you need to have to break weak separability in case in which only elimination rules confer meaning, because in this case we have that the subtraction does not depend on bottom, but bottom is needed to prove the sequent. And of course, the dual happens for dual intuitionistic logic. So we have the same problem with top and the identity sequent with a imply B. So the situation is this. We have that the system is still circular when both introduction and elimination rules confer the meaning, and it is even non-harmonious when only elimination or only introduction rules confer meaning respectively. Now, the fourth and last variation is essentially a combination of the second one and the third one. One could think of using primitive top, primitive bottom, so to have a defined negation, together with Puritan rules. The Puritan rules that are, of course, acceptable in the intuitionistic and dual intuitionistic logic. So we have, essentially, we build the system in the same way, but starting with the Puritan, the semi-Puritan intuitionistic logic and the semi-Puritan dual intuitionistic logic. Now, what we have is that in this case, the systems are non-circular regardless of the position on rule priority. The problem is that these systems inherit in harmony from both the Puritan, semi-Puritan version and the version with top and bottom. So we end up with a situation like this. Yes, we have non-circularity everywhere, okay? So like in the first system, we used to have harmony everywhere. In this case, we have non-circularity everywhere. But the cost is that we do not have harmony anymore when only introduction or only elimination rule is considered the meaning conferring for both intuitionistic and dual intuitionistic logic. So also in this case, classical logic behaves better. So the general morals are that in all formulations, classical logic behaves at least as well as intuitionistic and dual intuitionistic logic. I would say it behaves better than intuitionistic and dual intuitionistic logic. So it was taught that in a single conclusion framework, classical logic does not have presentations acceptable from an inferentialist standpoint. We have seen that when we change to the more symmetric single premise, single conclusion framework, classical logic does have such a presentation. So a conclusion that we could draw is that probably what matters for classicality is not the amount of conclusions, but the symmetry of the framework. So general conclusions, we briefly viewed the motivations of formula inferentialism. We presented cut-free first-order formula sequent calculi for classical and intuitionistic and dual intuitionistic logic. We put forward the meaning theoretic criteria for their assessment and compared the system with those criteria. And we concluded that classical logic behaves better, I would say. And as lines for future work, we have in plan an analysis of stability to investigate G3 variants of the calculi, so that is with admissible contraction and weakening. And moreover, to considerate non-vicious forms of circularity, since there are various authors that suggest a distinction between vicious and non-vicious forms of circularity. As an example, Roy Dikoff. So, and these are the references, and thanks.